Hi everyone, welcome back to our critical thinking course. You can pause this video anywhere you'd like to find out a bit more about what's said or what you see. For this week, you need to review the following topics from earlier reading, and then I'll introduce our new topics of argument structure and argument diagram. Okay. So here are the terms. Are you familiar with all of these terms? Okay, what's a conclusion indicator term? These are terms, that is, words or phrases, that indicate the term is probably being followed by a conclusion of an argument. Examples are therefore, so, I conclude that, now we know. The word then is not a reliable conclusion indicator term. Okay, how about premise indicator terms? These are terms that indicate the term is probably being followed by a premise of an argument. Examples are because, since, assuming, suppose. The word if is not a reliable premise indicator term. Unstated premises, or implicit premises as we more usually call them. Okay. What are those? Whoops. Let's try that again. Okay, these are unsaid assumptions that need to be part of the argument in order to make it a reasonable argument. If I say, of course he's mortal, he's a man, isn't he? Then I need to assume if he's a man, then he's mortal, although I did not actually say so. If I'm not assuming this, then I don't have much of an argument. Okay, how about valid? This is a technical term in our course, even though it's used more casually in ordinary conversations. An argument is valid if the argument's conclusion absolutely must be true whenever the argument's premises are true, even if the premises in fact are not true. Sound. An argument is sound just when you can hear it. No, just kidding. An argument is sound just in case it's valid and all its premises are in fact true. Strong. An argument is strong when it wins arm wrestling contests. Now, an argument is strong in our technical sense when it's valid. Try that again. The word strong applies to inductive arguments. A strong argument is not quite valid, but it's highly likely that the conclusion is true if the premises are too. Some people just use the word good when they rate arguments, and you can't tell whether they mean strong or they mean valid. In our course, we won't use the word strong in this informal way as just being a good argument. Okay, inductive. Inductive arguments are arguments that are intended to be strong. The speaker is trying to get the conclusion to follow with high probability and not with certainty. deductive. When someone offers a deductive argument, they intend the conclusion to follow with certainty and thus to be valid. Okay, I hope you remember what all these terms mean. Take time to review them for yourself. We're going to be using them all semester long and in discussing other topics. When creating an argument, reasoners sometimes present their premises first and sometimes present their conclusions first. We, the logical detectives, the listeners, the readers, never know which claim is a premise and which claim is a conclusion until we think about the structure of what we're hearing or reading. The indicator terms are useful, but they're not always there, and they're not 100% trustworthy. There's no escape from doing the detective work. Now for the topic of the day, argument structure and diagrams. This week, as you draw diagrams for arguments, you might ask yourself, why am I drawing diagrams for arguments? Well, if you're out in the streets, normal conversation, so to speak, out of the ivory tower, you're never going to pull out a pencil and pad and start diagramming somebody's argument or your own argument. That's not the point. The point is that if you're able to diagram an argument, you're going to understand its structure. And its structure is essential to assessing what argument you're presented with. You know how the parts are put together. And that diagram that you'll draw is somewhat similar to, if you imagine you're having a little video projector going on in your mind, it's like what you see on that video screen in your mind. So if you can understand the structure of arguments, and you can display and you demonstrate that by drawing these pictures, then when you throw away the pencil and paper and you're out there in the world, you're going to better understand the structure of arguments. This will improve communication, improve the ability to assess the quality of arguments, and it'll be a step forward for you. We use arguments in the creation of other arguments. Big arguments get supported with smaller arguments. Big arguments, these are the complex arguments, contain little arguments that are present to support some part of the bigger, more complex argument. Let's take as our example an inductive argument about buying computers. Suppose I'm arguing that you should buy a computer manufactured by the Dell Computer Corporation. As part of my argument, I explicitly state the assumption that we need to buy some computer or other, and then I include another argument that tries to convince you of this assumption. This assumption then is also a conclusion. We say it's an intermediate conclusion on the way to the final conclusion of buying the Dell. I'm now going to repeat everything I just said while introducing a method of drawing a picture that diagrams the relationships among the sentences in all the arguments. Here's the inductive argument that we'll start with. What's the final conclusion being drawn from this passage? What's the takeaway? We should buy a Dell computer. Not just any computer, right? Notice that the phrase, I think, is discarded. The speaker isn't trying to convince you that they think this or that. They could do that just with a tape recording. They're trying to convince you actually to buy a Dell. So we discard the fluff phrase, I think, from the conclusion. Now let's relook at the passage and analyze it slowly and use our diagram method. I'll start by listing all the important parts of the argument and its sub-argument. Now, the words in brackets are not part of the claims. They are the indicator phrases and linking terms that help us see the actual claims. Now, let's add arbitrary labels to the claims so we can draw our diagram using the labels instead of the full sentences. D is our final conclusion, the bottom line, so to speak. There isn't any special reason to use the letter D instead of the letter E or the number 88. It's your choice. Notice that two sentences were labeled with the letter C. Why is that? Why did they both get the same label? Well, the answer is that they're saying the same thing with different words. They make the same claim differently. Or another way of saying that is they express the same proposition. Now to the diagram. The diagram is like a sketch of the argument, or it's the content of your mind's video screen that displays what you understand when you understand the reasoning. Let's start the diagramming with the main argument and leave out the sub-argument for a moment. Here's the main argument. Conclusion supported by two premises. What's our diagram for that? Here it is. In these diagrams, the lines are like downward pointing arrows from premises to a conclusion. Conclusion that the premise supports. So premises C and B support D separately. There are two separate reasons for D. In these diagrams, the lengths of the lines are irrelevant. If the line from C to D were longer than the other one, the diagram would still contain the same information. Now let's look at that sub-argument for C. C says we need to buy some sort of computer. Okay, what's the diagram for this sub-argument? There it is. It's just P supports C. So there's a line of support from the premise down to this intermediate conclusion, which is the premise in the bigger argument. Okay, let's step back and look. We have two diagrams now. And now it's time to complete the diagramming by connecting our sub-arguments together to display the overall structure of the complex argument in the original passage. The two arguments can be fitted together into a single diagram. And this is the overall diagram of the passage. The intermediate conclusion is C, that we should buy some sort of computer. The speaker hopes this is a strong argument in support of the final conclusion, which is D, that we should buy a Dell computer. Once you get familiar with diagramming, I hope you'll be able to take a passage like this and go straight to this complex diagram and skip the sub-arguments and the pasting together of them. Just include the sub-arguments at the same time. Now let's work on some concept checks or sample questions to see how you do with this diagramming. So assume for the next three questions that the quotation contains a sensible argument with a word or phrase taken out and replaced with a blank. Choose the best way to fill the blank. Now look at this question about diagrams. What do you think the answer is? Can you draw the diagram? Okay, sure. Here goes. Does that look like your diagram? I hope so. Okay, let's now consider adding implicit premises into our diagrams. First, you have to find the implicit premises, then you have to figure out where to place them within your diagram. Okay, so how about this one about whales? Diagram the argument and add the implicit elements into the diagram. Okay, so I gave you a little head start there with the main part of the diagram. Right? So this is the fine diagram for everything said explicitly, but if you look between the lines, there are implicit elements. You'll see that, look at the sub-argument from 1 to 3. It's ridiculously weak because we probably left something out. Just suppose Humphrey is my cat's name and not a whale. We'd better add the obvious premise in order to keep the argument from falling apart. What is that obvious premise? You got it, right? Humphrey is a whale. Okay, now that's the premise we need. How would you diagram the argument? Where would you add in the for? That is, add the for into here somewhere. Okay, you got it? Right. It's another reason to support 3. 1 and 4 are the two reasons for 3. Now support goes down to their premises. So 2 is the line from 2 to 1 does not go from 2 to 4. So 2 doesn't support 4, 2 only supports 1 in a diagram like this. And 4 supports 3, it doesn't support 1 or 2 because support goes down. Okay, so we've got a reasonable argument now about Humphrey and the whale. And if Humphrey's only a cat, then not a whale, then the argument falls apart, right? By the way, the sub-argument from 2 to 1 there is inductively strong. Why? Because biology teachers are the right sorts of experts for simple biology questions. Right? That's the argument involving these two sentences. But the argument from 1 and 4 to 3 is deductively valid. It's airtight. So the moral here is that the usual way we detect implicit premises is to see what's needed to keep the argument from falling apart. One of the key elements of our detective work. Okay, adding implicit premises is fine, but you'll want to subtract out of the diagram all the sentences that are not premises or conclusion. For example, what should you leave out of the diagram of the following argument? Okay, notice the discount statement. I know she denied being at the crime scene. It's relevant to the discussion, but it's neither a premise nor a conclusion, so leave it out of your diagram. The discount statement's there to say it would hurt our argument if she really was not if she really were not at the crime scene, but nevertheless, we still draw our conclusions for the reasons given. Now, with that in mind, can you diagram our argument with this dictionary? Okay. It's from 88 to 77, right? From 88 to 77. Not. Think again, right? It's from 77 to 88. Okay, let's try some more sample questions that'll probe some other areas here. Select the best diagram of this argument, okay? Now this is spread out across multiple screens, so I'm going to have to show it to you and then go back and show you stuff that I showed you before, like this main part of the argument. Okay, you understand it? So you could pick your answer from these choices, right? How do you think about this? Well, you look for the main conclusion they're trying to get at, what supports it, and is there any support for that support? Is that the answer? A, B, C, D. Okay, so I'll let you look at those again. Find the answer is in one of those four, right? Which one would you choose? Okay, there's your choices again. You chose the first one, right? It's just a conclusion with 3 reasons given in support of it. Okay, here's another question. Let's look at the relationship just between 1 and 4 in this passage. Okay, if you look between the lines, you'll see that 4 is likely to have been expressed to support 1. Right? It's not as easy to see as some of the previous passages we've had. So go back and look at that if you couldn't see that. Hit pause, go back, backspace, or rewind or whatever. Okay, let's try another question. Okay, here's a larger passage. So I've given you a dictionary that defines what the symbols mean, in this case, the numbers. And then you'll be able to choose from a list of possible answers that I'm going to give you now. And pick the one that you think is right. Or is it one of those? So you have 5 choices. I'm sorry, 6 choices. 5 diagrams, and then the 6th says it's not one of those diagrams. Let's go back and look at that again. Okay, so here's the argument. With an explanation of what the symbols are. And then diagrams using those symbols. Is the answer one of those? Or is the answer one of those? It was the first one again. You left out all those other sentences. You didn't need those other numbers in your diagram. Okay, we're all done. We have reviewed a wide variety of technical terms in preparation for what's ahead, both this week and in future weeks. We'll be spending a lot more time explaining how to use that word valid and sound and so forth, and strong. Okay. And we've learned a lot about argument structure and argument diagrams. Bye for now.